Morning, folks. How are we all doing? You good? Welcome to the session today. Being presented by Bill, Pro Services Engineer at Jamf. And some of you folks might have been trained by us recently. Hands up, who's had a training session with Bill? There you go. Familiar faces indeed. So here we are. I'll hand it over.
Great. Thanks, Ben. All right. Good morning, everyone. If you're curious about Jamf training at all, find me sometime after the session today. Pick my brain. You can ask me anything. As Ben so eloquently and kindly said, my name's Bill. I've been a trainer at Jamf for about 2.5 years now. I teach the 200, the 300, the 370, and the 400. And the 300 and the 400, we talk about serialized data formats. That's kind of what I tend to call them. That's kind of how I summarize them. And especially in the 400, it's a subject that is a pretty large portion of being able to complete maybe the exam. And when I set out for proposing this talk, I had the mindset of, all right, if I had an extra hour in the 400, what would I use it for? Right? What would I try to show? What would I try to teach? So what I'm going to try to do is show you what maybe in a 400 I'd probably try to show you over a Zoom screen share with some frantic mouse movements or something over a text file. Instead, we've got a nice keynote with some hopefully useful information in there. So I couldn't resist while I was putting this talk together, procrastinating, going around on random websites on the internet. I found a quote by Alan Kay, and I couldn't resist putting it in here. What is data without an interpreter? And when we send data somewhere, how can we send it so that its meaning is preserved? Right? There's data. There's data in our Jamf Pro servers. There's data in our Jamf School instance. There's data in our Jamf Protect instance. There's data on our file system, on our Macs. Right? There's settings that we might want to configure on our iOS devices. There's some information, some data. And we need to send it, or we need to receive it, so that its meaning is preserved. Right? So the meaning, if we just take a bunch of data, throw it in a file, it's going to be just a bunch of bits, bunch of bytes, bunch of letters and numbers and symbols. What gives it meaning? What tells us what the relationships between that data inside of that file are? And the three formats that we're going to talk about, XML, property list, and JSON, right? We deal with these when we talk to the classic API. A lot of other web services and maybe older APIs use XML. Our property list we see all over our file system on our Mac. Preferences, configuring background tasks, configuration profiles especially, right? And JSON, some application configuration on macOS. A lot of modern web APIs, including the Jamf Pro API, the School API, and the Protect API. So these formats give meaning to that data that came from some computer program running in a cloud, running on a server, running on our Mac. Somewhere in memory, somewhere in the program's memory, there's some data, there's some information, and it has meaning because that program thinks that it has meaning, believes that it has meaning, uses it for something. And when we need to transmit that data, it needs to be serialized. It needs to go down into a format that preserves all of that meaning. So, unfortunately, there's not a ton of overlap. There isn't some example that I could pick, or at least one that I could think of. If you want to make me mad, find me after the presentation and tell me, oh, you could have just used this as an example of something that is typically found in all three of these formats. right? Definitely you can find things in XML or in JSON that kind of relate to the same data, but then property lists kind of left off all, all on its own on the side. And I wanted to avoid also using what I call the foobar Baz examples, where it's just, okay, we're going to take some data and it's all made up and it's all gibberish, because it's just a little too esoteric for me. So we're going to pretend. We're going to pretend we work for an organization called AnyOrg, and we just had a meeting. We had a meeting, and it was one of those meetings. It was a lot of fun, and we were taking some notes, and we were doodling. And we sat down with managers. We sat down with our finance department, right, our asset managers, and we decided, hey, it's the middle of the year. Maybe we need to reassess which Macs we're buying for people, what accessories that we're going to support, what goes into the standard staff computer kit. And this is a mess, right? We had a meeting. It was maybe an hour long, and there was a bunch of back and forth, a bunch of vibrations going around in the air that have some meaning to all the people who were in the room. They remember it, but my team needs to know about this. So I took some notes, and as it usually happens when I take notes, I get bored, I get distracted, I start doodling. So I have some things that I need to do, right? I have a couple builds that I forgot to click here, and right. So this is kind of hard to read, right? It's a mess. So if I tried to clean it up, pop open a text editor or something and type it up, right? I could type it up like this, send it to my colleagues, and here you go, this is what we decided on. But there's just some text here, right? It's kind of hard to see how all of this data relates. So if we were maybe typing this up in a text editor or in a Pages document, we might do something like this. Just indent a couple things and say, all right, well, here are the specifications for everybody, and then here's an extra choice for people who are in the development department or the IT department, right? Here's the two docs that someone might get on their desk, and the two displays that we'll offer as a choice with some information about them. All right. We give this data some structure, and with that structure, we see all of a sudden some collections start to form, some boxes that things can go inside of, right? Our groups now actually are visible. It's not just a word floating in a text document. It's, no, these are the groups right here. All org, development, and IT, right? Those two things, those two groups are themselves containers for a bunch of specifications. What actual computer are we going to order for these people? Right? We have a whole bunch of accessories. We've got a list of docs, right? 2 different docs that we're going to maybe have on stock, or maybe those are the ones that we'll support. And a list of displays, themselves, each with some information about them, themselves a container. So we took our messy notes, we took all those vibrations in the air, and we turned it into something that probably at first glance, our colleagues are probably going to understand. Right? There's a lot of explicit meaning and data that's been placed onto this page, but also a lot of implicit meaning that we've given it just by knocking something in an indentation level. Right. The collections are the part that I really want to focus on, though. Okay. Come on, slide. You got it. There we go. Okay. So inside of here, we've got a lot of other data. Inside of those collections, there's some things that are a programming language or a serialized data format might refer to as a string, right? It's just some words, just some numbers. We have actual numbers, real number types, something that is not 18 gigabytes, but just the number 18. We have true and false, some yes or no, yep. This monitor does provide power delivery. This one does not, okay? And our container formats, either a dictionary where there is a set of keys and values that have a name, or an array, which is just a list, right? The collections themselves, they do the same thing. They collect, they sort of wrap up, they put into a box a bunch of things. The difference between an array and a dictionary is simply that an array, you ask for something by a number. Get me the second thing out of the box. Get me the first thing out of the box. Whereas a dictionary or an object, you would maybe ask for it by its name instead. Get me the all org box. Get me the development and IT box. So there's a pretty decent amount of data here, and these formats can get a little long. So what we're going to do is we're going to take a look at a smaller part of this data first. And we're going to take our staff computer specifications, our any org mac kit, and we're going to turn it into XML, we're going to turn it into PLIST, and we're going to turn it into a JSON. So first, in XML, XML, without getting too deep into the massive specification, you can read it if you want. It's really dry and boring. Doesn't really have like a clear concept of a type. There are a lot of annotations and things, a lot of attributes that you can add to an XML tag that might denote a type, but the kinds of XML that you deal with when you're working with the classic API generally do not, right? So when we have some piece of data like the model, right? We're gonna buy a 14-inch MacBook Pro for everyone who isn't in development and IT, or if they're in development and IT and they would prefer a smaller MacBook Pro, they can choose that one as well. So we have two pieces of information there. We have model and we have MacBook Pro. So in XML, the thing, whatever the meaning of that data, would go inside of the tags and give this information a name, right? It is the model, right? That model is a string, right? It's denoted really by nothing other than us reading it or the program that is ingesting this or sending it out. Right. All of the other information in there is going to generally follow that same pattern, where we take something about the meaning of the data, put it into the tag as its name, and put the data inside, hoping that the types are right. Right. So we have a bunch of data, right, 4 data points that all belong together to the all org spec. How do we put it in the box? How do we put it in the all org box? Well, we just throw some tags around it, right? Tags can wrap data, they can wrap other tags, right? And now all org is the parent attribute, the parent tag of all of these 4 data points here, right? And if we squint and maybe erase a couple things, right? It looks a lot like our outline, our notes that we typed up and indented and organized a little bit, made it easy for our colleagues to read, right? We do the same thing in XML. We indent child tags, child elements, usually 1 level, right? Now, if I take this information and I want it in a PLIST, first, there are different kinds of PLISTs. There are binary PLISTs, there are XML PLISTs. They refer to how the actual information is encoded in the file. But if you take a binary encoded PLIST, hit the space bar on it and take a look at it in quick look, it's going to show it to you in XML. Right? The Finder assumes You don't know how to read binary PLIST. I don't know how to read binary PLIST. I'm not a computer. But in an XML PLIST, what we get is we get an extra slot, right? What we're looking at here, we've got one slot in the name of the tag, and then the actual data. There's nowhere for any type annotations to go. In a plist, we put the type annotation inside of the tag. So we don't really name this data a string. We just say the data inside of this tag is a string. And if we need to give it a name, which we do here, right, we throw that in a model tag or a model key, right? So now we have an explicit key, and then immediately following it is the data that relates to that key. In this case, we know it's a string because it says it right there in the name. Right? If we add the rest of our attributes in here, all of the strings generally look and work the exact same way. For our memory in gigabytes, right, now we can actually say, no, this is an integer, right, which lets us check if someone is going to modify this file, or we're getting this file from a file system or anything like that. If someone accidentally types in 18 GB for that value instead of just the number, now we can check it. Now we can actually say, no, that's actually incorrect. That's not the data that's supposed to go there because it's not the right type. Let's put our collection back in here. All right, so we have our key up there at the top, and then dictionary tags that say, hey, this is a collection, an unordered collection of key and value pairs. They themselves could be simple key and values. They could be a key, and then that key could relate to an array. That key could relate to another dictionary. Right? Dictionaries all the way down. So let's throw our XML back up there. Right? We can see the XML plist gets a little long. Right? There's a lot going on there, but it's the same data. And generally, if you kind of squint, it's about the same shape too. We still use that indentation to denote relationships because the tags are really just there for the computer programs. Now, if I take this same data and turn it into a JSON, it's all still going to be here. But now, instead of there being tags or names in XML tags explicitly saying this is the key and this thing that comes after it is a dictionary, the type data is there, but it's sort of encoded in a much smaller amount of markup, right? The JSON wraps objects in curly braces, strings go in double quotes, integers are just numbers on a line, right? It's just an implicit, this is an integer because they're numbers and there's no quotes around them. Let's throw all the rest of them back up here, right? Exact same data, and if you squint, it all kind of looks the same as our notes that we wrote up there. So let's take a look at our accessories dictionary down there at the bottom. Our development and IT sort of specification is going to look pretty much the same as our all org one because it has the same attributes inside. So let's do the accessories here, right? Our accessories consist of two types of accessory. We have docs and we have displays. The docs were in a list. They were just listed without any other information, just here's the name of the doc that we're going to buy. And in XML, the lists generally look the same as sort of unordered ones where it's something that would probably be a dictionary in a plist or a JSON, right? XML doesn't really have an array type. So we have to wrap that data up somehow, so we wrap it up in just maybe a doc tag, right? Instead of docs, it's one doc. One of them is the OWC Thunderbolt Pro, the other one is a cal digit. Our displays, right? We have two displays in our list, but there's lots of information about each of them. So I wrap each of those up in a display tag to give it some meaning. What is this data relate to? What is it for? What does it say? It says, well, this is the name, the model, the spec, power delivery, yes or no, for one of the displays in the list. Right, turning this into a PLIST in XML, right, now we have an extra spot. We have an extra slot to store that type data. So the displays just become two strings, because that's what the data is. It's just a string inside of an array. There's two of them. The one thing that's different here, though, is the data that is inside of the array. Each of the elements in there doesn't itself have a name, right? That's where the word dictionary comes from, where there's a key that gives a value a name, and then the value itself works a little bit like an English dictionary. There's a word and then a definition. Arrays don't have key names, right? It's just some type, some data. All right. And the same thing in JSON, right? The information is still all there, right? There's not that much that's implicit, but instead of curly braces saying that this is an object, this is a dictionary, we now have square brackets denoting that, hey, these things are in an array. So that's some data, and those are some formats, and those are some keynote animations, and that's pretty cool, right? But if you remember why I'm giving this talk, it's the extra hour of the 400 that I don't have time to give during the week. Knowing how this data is structured, being able to read this, figuring out how this data relates to itself and to the things that wrap it up and put it in a box, right? It's key to telling a computer how to find that data out of that file. If you're running through a bunch of scripts, talking to the API, you're getting data down in a JSON, you're getting data down in an XML, I need to pull the username assigned to every single iPad in my organization. I need to know which policies that I have that are disabled, or have the word delete me somewhere in the title, because, yeah, I'll delete it later. We know that later never comes. Right? And I have 1,000 policies, and I don't want to have to do it manually because I'm lazy. Right? So understanding the structure of the data that we get from these APIs, it's key to understanding how to tell a computer, how to tell some command line tool how to get the data out of there. Because I don't want the whole thing. I'm just after the title of the policy. I'm after the username attached to an iPad. So if I can get to the data, the other nice thing is that I can also tell it to change it if I really want to. Right? And we have some data that needs to change because they caught us. They looked at the spec and they were like, 128 gigs of RAM? I don't think so. That's maybe a bridge too far. They weren't too happy with us. And also we figured out that the LG Dual Up, it's a great display. Comes with a really nice stand and clamp that clamps onto the desk, but the clamp just doesn't fit the desks that we have. Right? All of our hot desks, our hotel desks, they don't really work that great. And if we have to go buy new stands for all of them, we might as well just go buy a different display. So we need to get rid of the LG Dual Up from our list of displays that we're going to support or offer, and we need to modify our memory specification here. Now you'll have to excuse there was a font missing, and that's why that circle's a little off. But that's the data that we're after. We've got a display down there at the bottom and then a number somewhere in this XML or in this outline here. And if this is all I needed to do, if this was in a text editor, I could just go point my mouse at it, click on it, and hit backspace a couple times, maybe do a drag and select and delete a couple lines at a time. But if I want to do this in an XML file or in a JSON or in a PLIST, then I don't want to break any of that structure, any of the stuff that makes these formats machine readable. So I have to well, I don't have to, but I should prefer to use tools that preserve that structure while allowing me to make modifications. So if we look at sort of all of this in an XML or in a property list, right? That's why the binary PLIST format was created, because XML property lists get really long. Or in a JSON, right? I need to kind of figure out how to walk my way to that data. So let's take a look at this in XML. All right, we have the sort of a root tag there up at the top, a root element, or any more org mac kit that just sort of defines what is all of the data inside. What does it relate to? What is it about? So that's a first step. I have to sort of go into this any org mac kit element to find the data that I'm after. Right? I have to go into groups and find the data that I'm after. I have to go into the development and IT collection, this thing that's wrapping up the data, right? It's another step towards my memory specification, right? And if I just sort of squint and back out and ignore everything else, these 4 elements here form a sort of path towards the data, right? And if this was a file path, right, I'd probably put forward slashes, maybe backslashes on a Windows computer, right? That would describe where the data is at, right? And luckily for XML, that's all I need, right? The command to pull this out of a file on a Mac using XML lint -- XPath is going to take that exact thing as an argument. It's going to say, all right, well, where's the data you want me to pull out? Well, it's at any org mac, mac kit, groups, development and IT, and the memory _GB, right? That text and open and close parentheses, that's an XPath function that just returns the value on the inside, right? So if I can get to it, I can probably change it. Now, XML and XPath isn't really a great modification language. It's a query language. For making edits to XMLs in a shell script or something like that, there is something you can use called XSLT, but it is something that I don't know that we have a ton of time for. It's one of those things that I'm gonna assign y'all as homework to go and look up later on. Right? Go and take a look at some XSLT for making transformations to XML. So we won't be modifying this with any XML tools or anything like that. But I can lose my screen somehow? Okay, we're back. Oh, I hit the wrong button, that's why. Right, I can run this and get back the number, right? I know I'm on the right path at least. Because I can get back 128, which is what I expect. So let's take a look at property lists. Right, property lists, finding the path to the data, figuring out how to walk to it. Right, it's going to look similar, the tools are going to be a little different, and we can ignore a lot of the sort of the top level stuff there. We don't need to explicitly state, yes, go into the PLIST element, right? We know it's a PLIST, right? And every PLIST generally starts with a top level dictionary. We don't need to tell it that either. So our first sort of top key that we need to go into, we need to walk along to get to the data that we're after is the groups key. So groups, right? We can ignore one of those groups because we're not going to be modifying anything in there. So we go to the development and IT group and then ask for memory in gigabytes, right? And just sort of squint and blur out any of the data that we're not after, right? So we have some keys, right? And this is our path, right? This is our key path. Depending on what tool you use to pull data out, The separators, right, over an XML lint, they were forward slashes. Depending on which tool you use, they might be a colon, they might be a period. All right, so if I have, if I'm using PLIST buddy, they would be colons. If I'm using plutil to pull this data out, it would be periods or full stops. So when I run both of these, I get back 128. It's a good sign. Again, that I'm on the right path. I can direct these tools to the value that I want to modify. So let's modify it. Right. Now, instead of telling PLIST buddy that I want to print that value there, I'm going to tell it, no, actually, I want to change it. I want to set the value to 64, which is still probably plenty for us. Right? plutil, I'm going to replace that value. Right? So we'll set both of those to 64. And as always, again, if you've taken a 400 with me, it's like a broken record. Trust but verify, right? Check your work when you're done. Right? Try to pull it back out again. Did it actually change? Right? Let's do the display. Right? We've got to yank that display out of here too. So down here we have our accessories dictionary. Inside of there, there's an array called displays. And remember, arrays, you can access things in them based on the index. Pull the index out. They start at 0, so the 0 index is the first thing. The first index is technically the second thing. Let's get rid of the stuff we don't need, right? We don't need index 0. We don't need any of that other PLIST data, not directly related to what we're looking for. I'm looking for accessories, displays, and then get me index 1. All right. So when I run this, I get back either the dictionary itself with the 3 key value pairs inside, or I just get back the keys. plutil will only give you the keys. Right. If I want to pull that out with plutil and actually sort of see what's going on in there, I can tell it, hey, output this as XML1. Right, and it'll start to print all of this stuff out. So if I have the paths right, it means I can probably modify that data. In this case, we're going to be deleting it, so that's a delete with PLIST buddy. It's a remove in plutil. And really, neither of them will give you much feedback. If it's able to delete something, if it can find the data at that path, and it's allowed to make changes to the file, it's just going to delete it. You're not going to get any feedback. But we can go back and check afterward. Hey, can you still pull that thing out from the first index of the array? No, it's not there. There's nothing there anymore. Right? Could not extract, does not exist. Means we were able to get it done. Right. Now, modifying things in JSON, it's an interesting quirk of timing this year, where there is a new version of macOS out that has a new tool that I did not have a chance to put into the presentation because when I made this, Sequoia was still in beta. I didn't know when it was going to be released. But since Monterey, plutil can use the exact same key paths to manipulate and extract data from JSONs as well. You can also use it to convert property lists into JSON. You can use it to convert JSON into property lists. It's pretty cool. And since the data is structured the same, you can use the exact same key paths. Right? Finding it works the same too. But this wasn't meant to be a comprehensive review of every tool. Right? The new tool that's in Sequoia is called JQ. It's been around for a while. It was always one of those things you had to install yourself. Now that it's built into the OS, now it's, for me as a trainer, it's something that I feel like is more fair game to talk about. The commands themselves, plutil, PLIST buddy, XML lint, they all have excellent manual pages that I didn't come here to read to you. And I would not be able to do it any justice anyway. Those manual pages are all written very well. But I started this off as this was sort of the missing lesson. This is what I wish I could show people in a 400, wish I had time to show people in a 400, without having to just sort of frantically use a mouse and just go, look, it's all grouped together, because I know that it doesn't really work. You know that a lot of this is just trying to get through all the practice and the reps that I've gotten in on this, right? But ultimately, interpreting this data is really just about being able to squint and look past this heavy structure, this messy, this noisy, sometimes invisible markup, this implicit markup, and see that the structure, the way the formatting is, the new lines, the tabs, tell us enough that we can maybe navigate to the data that we're after, and that the data that is in here and the way it's structured isn't all that different than how we would write it down in a notebook or in an outline or in notes that we would hand to a colleague. So I made it the whole presentation without making a Star Trek reference, which is impressive. So I'm going to end on one. The 74th Ferengi rule of acquisition says that knowledge equals profit. The title of the talk was Exploring Serialized Data Formats for Fun and Profit. I hope you had fun, and I hope that you were able to learn a little something, because hopefully that's where the profit's going to come in. Thank you very much for attending. I know that it's early. I'm like ready to go take a nap. Yeah, I appreciate your attendance. If you have any questions, I think we do have time, a little bit of time for Q&A. Otherwise, thank you very much. Enjoy the rest of your JNUC.
So do we have any questions?
Hey, good morning. My question is mainly around those tools, the ones that you've referenced for querying files, and how often you tend to find yourself having to develop something more custom with those native tools for things like custom attributes or other informations that you use for dynamic scoping.
So most of the time, if you're thinking about like an extension attribute, a script to read some value out of a property list, a lot of times you don't need to use something as complex as PLIST Buddy or PLUtil, but sometimes you do. And that sometimes is when you find some property list file that has a structure that isn't as flat as most preferences. Like a preference file, generally it's just that top level dictionary, and it's just a bunch of key value pairs, because it's preferences. It's this box is checked, this box is not checked. They have their theme set to this, or it's set to this. If you're after information that is inside some other collection, and you need to pull information out of there, default isn't going to be able to let you do it. So you kind of have to use PLIST Buddy. You kind of have to use PLUtil to go a little bit deeper in. I hope that answers the question.
Kind of. I'm more so asking around like what use cases you've found in your time.
I mean, as far as extension attributes, pulling stuff out of JSON files or property lists, I mean, there's a lot. Trying to think of one off the top of my head. A great example is there is a property list in, I believe it's like Macintosh HD, like the root library preferences folder that contains all the known Wi-Fi networks, right? What networks have people connected to? Do they have my networks that I want them to be connecting to in their list of historical networks that they've connected? what's the information about those? What base station ID is it connecting to? Does it have auto join enabled? That property list is not, it's not like a simple one. It's very complex, a lot of nested data structures, a lot of nested collections. So if you wanted to pull that information in, those tools would be sort of the ones you have to use. As far as just in general, pulling stuff from property lists on a Mac, or pulling JSONs to sort of read preferences or something like that. I mean, I'm sure we all have it, you know, could probably pull up our production Jamf Pro servers and find tons of them. So yeah, I hope that helps. I can't think of any better examples off the top of my head. That's a great example. If you didn't hear, figuring out what the default web browser is. You have to query the launch services plist and figure out what the, you know, the handler for HTTP and HTTPS is, so that you can maybe just report on it. Maybe you just want to know, hey, what browsers are people installing? We can find that out inside of Jamf Pro, but maybe we need to figure out which ones they're preferring to use. So that's a great example. Thank you for that. Just one other question.
What was the new tool that you referenced that was available in Sequoia?
It's called JQ, short for jQuery, and it has its own sort of separate syntax for working with JSON specifically.
I know it might be a little off topic. You're a 400 teacher. What tutorials would you recommend before taking your 400 class? Just to level up a little bit on the bash or whatever.
I would first take a look at the developer.jamf.com webpage, kind of get comfortable moving about the API references. There's also a lot of great just sort of resources and articles linked there that don't necessarily have to do directly with an API about like writing background tasks, launch D tasks, and things like that. As far as scripting, it's a language, it's a thing you have to exercise, so I always kind of toss it back as what problems do you need to solve, right? Try to figure out some problems that you need to solve, and maybe even ones that you've solved already, but then pretend that you have one hand tied behind your back and you only have access to a keyboard, right? How do you make a script do what you could do pretty easily with a mouse and keyboard? Now just do it with a keyboard and a terminal, right? Is it possible? Can I do it? Because there's no substitute for practice beforehand.
Thanks.
Anybody else? Going? Yeah? Okay, I think that's it. Thank you again.
Cool. Thank you all.